Homework 17, starting out the trig section of your pie chart, and because we're going to be working a lot with angles, we're going to start by converting degrees, minutes, and seconds to just decimal degrees. So we have 3 degrees. We're going to have 3 plus. We have to change our 36 minutes in terms of degrees. There are 60 minutes in 1 degree, so we'd have 36 over 60. And then we've got to do the 29 seconds. Well, when we think about 29 seconds, there are 60 seconds in a minute and then 60 minutes in a degree. So we would have 60 times 60 that we're dividing by, or 3,600 seconds in a degree. So we're just going to use our calculator. 3 plus 36 divided by 60 plus 29 divided by 3,600. And I get 3.6080. I'm rounding to the nearest thousandths, which is 3 places after the decimal, tenths, hundredths, thousandths. Since it's followed by a 0, I'm going to say 3.608 degrees for my answer then. So number 2, same kind of thing, 11 degrees, 26 minutes, and 38 seconds to decimal degrees. So 11 plus 26 over 60, since there are 60 minutes in a degree, plus 38 over 3,600. And punch that in. 11 plus 26 divided by 60 plus 38 divided by 3,600. And I get 11.4438. Since I'm rounding to the thousandths, a thousandths is 3 decimal places. I want to carry it 4. And so behind there is an 8, so I got to round it up. So 11.444 degrees is what I would round that off to. And number 3, same kind of thing, 4 degrees, 42 minutes, and 20 seconds to decimal number of degrees. So 4 plus 42 over 60 plus 20 over 3,600. And I get 4.7055, so rounding to the nearest thousandths, 4.706 degrees. On the next part, we're going to take it from the decimal equivalent and change it into degree, minute, and second form. So the 35 in front of the decimal is the degrees. So I'm going to have 35 degrees. I'm going to take the 0.955 times 60, since there are 60 minutes in a degree. I hid my calculator. I got to grab my calculator here. So 0.955 times 60 gives me 57.3. So the 57 in front of the decimal is the minutes. I'm then going to take the decimal remainder, the 0.3, times 60 again to change that into seconds. So 0.3 times 60 gives me 18. So we have 35 degrees, 51 minutes, and 18 seconds for our answer. So number 5, going to be the same kind of thing. The 127 is the degrees. We have 0.592. We're going to multiply that by 60 to change that into minutes. So 0.592 times 60 gives me 35.52. So the 35 in front of the decimal is the number of minutes. We're then going to take that decimal remainder, the 0.52, times 60 to change it into seconds. So 0.52 times 60 is 31.2. We're rounding it off to the nearest second, and so 31 seconds. So 127 degrees, 35 minutes, and 31 seconds would be your answer. I'm going to go ahead and move the board up. You go ahead and start the next one and see if you get the same thing I do. So on number 6, we've got 44 degrees. We're going to take the 0.555 times 60. So 0.555 times 60 gives me 33.3. So we have 33 minutes. And then we got that 0.3 again, which we did on the first problem. 0.3 times 60 was 18. And so we have 44 degrees, 33 minutes, and 18 seconds. Seven, 8, and 9, we are converting between degree measure and radian measure. We're used to measuring things in degrees. Radians is really equivalent to that, but it's a different form of measurement, kind of like feet and meters are different forms of measuring the same kind of thing. They're used to measure an angle, but you can measure it in degrees or you can measure it in radians. 180 degrees is equal to pi radians. So when I'm going from degrees to radians, I'm going to take my 210 degrees and I'm going to multiply it by pi over 180 degrees so that the degrees cancel each other out. When I do radian to degree, I flip my fraction the other way around. So in this case, if I was simplifying this, obviously I could cross off the 0 and make it a little shorter, 21 pi over 18, dividing those each by 10. I look again and say, oh, I can divide those each by 3. So if I divide by 3, 7 pi over 6. So 7 pi over 6 radians would then be my measure. You'll usually see the word radian behind it, or sometimes I'll just put rad, and that's for radians, the abbreviation. So 210 degrees, 7 pi over 6 radians. If I want 11 pi over 6 radians changed to degrees, then I have 11 pi over 6. This time I want to cancel the pi out. So the pi is going to go on the bottom and the 180 degrees is going to be on top. So here the pi cancels out. I could do a little more reducing. 6 goes into 18 3 times, so it goes into 180 30 times. So I have to take 11 times 30, which is 330 degrees then. So 11 pi over 6 radians is equal to 330 degrees. Number 9, we're going from degrees to radians again. So 270 degrees, I'm going to take it times pi over 180 so that the degree measure cancels out. Again, I could divide by 10 and get rid of one of my zeros. 27 pi over 18. I can reduce that down again because I can divide by 9. So 3 pi over 2 radians. So 270 degrees is equal to 3 pi over 2 radians. It will take you a while to get used to radian measures. When we get to the pie chart, you're probably fairly comfortable with where 180 degrees is and 90 degrees and 45 is. But then you want to also start getting used to what's the equivalent. 90 degrees is pi over 2, so when I have pi over 2 radians, it's in the same place as 90 degrees on my pie, or on my circle. (10, 11, and 12, we're converting again between degrees and radian measures. This is problem type 2, so sometimes a little bit trickier. We are going to round our answers to the nearest hundredth. And so for pi, you could use 3.1415. Because of rounding issues, I recommend that you use the pi on your calculator. On the Casio, you hit shift And the EXP, you can see in yellow, the pi button is above that. And so if you just use the pi on your calculator, you won't have to worry about rounding. Otherwise, you need to carry out pi far enough that you don't end up with rounding issues. But same kind of conversion that we did before. If I have 149.41 degrees, in order to change it into radians, I'm going to multiply by pi over 180. So that means I have 109.41 pi divided by 180, and I'm going to put that into my calculator. Again, I'm going to use the pi button. So I'm going to put 149.41, shift the EXP button to show pi on my calculator, divide that by 180. I get 2.607. I'm rounding it to the nearest hundredth, so I want to carry it 3 places so I can round it off. So I have 2.61 radians then. So 149.41 degrees is equivalent to 2.61 radians. Number 11, same kind of thing. I'm going to go from radians to degrees. So I have 6 pi over 11, and I am going to multiply it by 180 over pi so that the pi can cancel out. So I'm going to have 6 times 180 divided by 11, and that's what I'm going to punch into my calculator. So 6 times 180 divided by 11 gives me 98.1818. But I'm rounding to the nearest hundredth, so 98.18 degrees is equal to 6 pi over 11 radians. 6/11 pi, however I want to read that. Number 12, same kind of thing. Here I have 224 degrees that I'm starting with. I'm going to multiply by pi over 180 so that my degrees cancel out. I'm not going to worry about reducing. I could probably reduce a little bit, but I'm just going to take the 224 pi, divide it by 180 since I'm using a calculator anyway. So 224, shift the EXP button to get pi, divide that by 180. I get 3.909, which would be 3.91 radians. And again, if you are or you do not have the pi button or don't want to use the pi button, I would recommend that you use 3.14. Probably want to go to at least 1/6. 3.14159, but you don't probably want to round it off too far or you may get rounding issues. So I would maybe carry it at least that far. Otherwise, easiest thing to do, just use your pi button and then you don't have to worry about rounding issues. Alright, so now what we're going to do is we're going to sketch things that are in radian measure onto our circle because you want to get used to the degree equivalent and the radian equivalent. So we said that 180 degrees was equal to pi. So over here is going to be pi. Over here obviously is 0. So if I just split that in half, up here is going to be pi over 2. So I've got 1 pi over 2, 2 pi over 2, and 3 pi over 2. Those are my 90-degree angles. So 90, 180, 270. These marks right here, the 45-degree angle, is cutting this in half. So this would be pi over 4. So I've got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. You can see that these ones we still hit, it's just that they reduce down because this would be 2 pi over 4. 2/4 is the same thing as 1/2 pi over 2. Now our other measures are our 30, 60 degree measures. So 30, 60, 90, all the other tick marks in there. 30 degrees is pi over 6. 30 goes into 180 6 times. So this is going to be pi over 6. So 1 pi over 6, this one's going to be 2 pi over 6, which is really pi over 3 if I reduce it down. So 1 pi over 6, 2 pi over 6, this would be 3 pi over 6, so this would be 4 pi over 6. And of course I can reduce that down again to 2 pi over 3. 4 pi over 6, 5 pi over 6. That one won't reduce down. Here is 6 pi over 6. Then we have 7 pi over 6. Again, that one doesn't reduce down. Here we would have 8 pi over 6, which is 4 pi over 3 if I reduce that down. 9 pi over 6. This one here would be 10 pi over 6, which would reduce to 5 pi over 3. And then we have 11 pi over 6. And then of course here we would be 12 pi over 6, which is the same thing as 2 pi, but normally we say that's 0 instead of 2 pi. We would get there eventually though, if I kept going around 2 pi, 4 pi, and so forth. So that's what your circle is going to look like for our regular measures, 90 degrees, 45 degrees, and 30, 60, 90 degrees. And so what they want you to do is sketch where that angle is in standard position. So 7 pi over 4 is way over here. You're going to grab this line, it's going to come all the way around, and you're going to drop it right there at 7 pi over 4. So my angle right here, and go from there. If we look at the next one, we're doing 5 pi over 6. So pi over 6 is 30 degrees. We've got 1 pi over 6. Here would be 2 pi over 6. Here would be 3 pi over 6. Here would be 4 pi over 6. Here would be 5 pi over 6. And so I'm going this way around. I'm going to grab that and I'm going to drop it right there, 5 pi over 6. So I'm skipping the 45 degree angles, but otherwise I'm counting every hash mark, 30, 60, 90, so forth. On the next one, we want to sketch 2 pi over 3. We can get denominators of 3 by reducing the pi over 6 ones. So what I'm going to do is I'm going to convert that so that the denominator is 6, because every 30 degrees, pi over 6. So 2 pi over 3 would be 4 pi over 6. So again, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, and so 4 pi over 6 or 2 pi over 3 is right there. I grab that, pull it up there, and that's going to be my angle that is equal to 2 pi over 3. So if you just remember those standard ones, here we've got pi over 2, here we've got pi over 4, and then these ones are each pi over 6 as I go around, and then of course some of them I can reduce down into lower terms. The next ones are talking about coterminal angles. When they talk about a coterminal angle, they're talking about an angle with the same degree measure. If I just happen to do 45 degrees, if I wanted a coterminal angle with 45 degrees, I could go backwards around. And so if I took the full circle, 360, and subtracted the 45, negative 315 degrees is the same thing as a positive 45 degrees. I'd end up in the same spot. And so those angles would be called coterminal because they end up in the same spot. If I start with a positive measure, I'm going to subtract 360 from that to find the negative measure. If I start with a negative measure, I'm going to add that. So I'm either going to add or subtract 360 degrees, which in radian measures is 2 pi. And so if I'm finding an angle that's coterminal with 2 pi, I'm going to take 2 pi and I'm going to subtract 11 pi over 6. Now if you kind of ignore the pi's, you're really just subtracting fractions. So I'm taking 2 minus 11/6. If I make my common denominators then, I would have 12 pi over 6, which is the same thing as 2 pi, minus 11 pi over 6, which is pi over 6. So what it's saying is, if pi over 6 is here, if I go the positive direction, that if I went negative 11 pi over 6, that I end up on the same line. That makes sense, right? I would end up in the same spot. So if I'm finding the angle between 0 and 360 that's coterminal with 495, what that's saying is I went around one whole time, but then I went around some more. Where do I end up? So I'm going to take the 495 and subtract the 360. Went around once. 495 minus 360 is 135. So I end up over here. And so 495 degrees going once all the way around plus a little bit more would land you at 135 degrees. So those are coterminal. They end up landing in the same spot if I keep going around. So if I'm going to find an angle between 0 and 360 that's coterminal with 1030, it's kind of like this one. I'm going to start with my 1030 and subtract 360. That means I'm going to go around my circle one time. 1030 minus 360 gives me 670. Now I'm at 670, I'm not between 0 and 360, which means I'm going to go around a second time. So I'm going to subtract another 360. Now I get 310, which is between my 0 and 360. So I end up somewhere over here because I didn't quite make it around another time, right? I have 50 degrees left, so I probably have just a little bit farther that I went. But that one I ended up going twice and then 310 more degrees. So if I want to find the angle between 0 and 2 pi that's coterminal with 27 pi over 10, it's kind of like this one here where I had 1030. I have to subtract 360 once around, subtract 360 until I get between what I want to be. Since I'm in radian measures, 360 is 2 pi. So I'm going to take 27 pi over 10 and subtract 2 pi until I end up with something that's between 0 and 2 pi. In this case, again, I have to find my common denominator. So 27 pi over 10 minus 20 pi over 10, because 10 times 2 is 20. 20 tenths is the same thing as 2. So when I subtract, I get 7 pi over 10. And number 18, if I move my board up here. Number 18, we want to find the angle between 0 and 2 pi that is coterminal with negative 5 pi over 2. So if it's negative, we're going to start with the 2 pi and subtract our 5 pi over 2, and we're going to keep going until we get a positive number because we're going backwards around our circle. And so here my common denominator would be 2. I'd have to have 4 pi over 2 minus 5 pi over 2. When I subtract that, I still get a negative pi over 2. So I end up having to repeat that process. I didn't leave myself much writing room, but I have to take 2 pi minus pi over 2 then. So 2 pi is 4 pi over 2 minus pi over 2 gives me 3 pi over 2. And the last one, we're starting with a positive angle, 601. I went around my circle once and then I'm going to go some more. So I'm just going to take my 601, subtract my 360. Make sure I clear my calculator first. I get 241 degrees. So, again, if you're starting with a positive number, you're subtracting 360 or 2 pi. If you're starting with a negative one, you're going to start with the 2 pi or the 360 and subtract your angle and keep going till you get that positive number. So, on the next ones, 19, 20, and 21, we're talking about arc length and central angle measure. So if I have my circle, the arc length S is the length of this arc that's intercepted by the angle. And this is a central angle, they call that theta, if there's a certain radius in there. So the formula says that the arc length is equal to the radius times the central angle. The central angle has to be in radians, and so if it's not in radians, we would have to change it to, if it's in degrees, we'd have to change it to radians. In this case, we have a circle that has a radius of 13 meters. Find the radian measure of the central angle that intercepts the arc with a length of 12. So they're saying the radius is 13, the arc is 12, we want to find that angle. So 12 is going to be equal to 13 times theta, and of course in order to solve that, all we're going to do is divide. Now we are going to round our answer to the nearest tenth, which tells me that I have to find where I stuck my calculator because I have to do some division. So I'm going to grab my calculator here. I'm going to take 12 divided by 13 and I get 0.923, rounding to the nearest tenth then, 0.9 radians would be the measure of that angle. So on number 20, it says a circle has a radius of 19 feet. Find the length S of the arc length, intercepted by a central angle of 155 degrees. Do not round any intermediate computations. Round your answer to the nearest tenth. So, S equals R times theta. The circle has a radius of 19. We want to find the length of S if we know the central angle is 155 degrees. Our problem there is that our central angle is in degrees instead of radians, so we have to convert our degrees to radians by multiplying by pi over 180. So we are going to take 19 times 155 pi divided by 180 and then round our answer to the nearest tenth. So in my calculator, 19 times 155, shift EXP to put the pi in there. You could put the times sign in between if you wanted, but you don't need it. Divide that by 180. And so I get 51.399 with a whole bunch of nines. I'm rounding to the nearest tenth, so 51.4. And I am finding the arc length, which is going to be in the same units as my radius. So that's going to be in feet. So 51.4 feet would be my answer. 21, I'm going to try to sneak in there so that we have our formulas and stuff. It says a circular arc has a measure of 20 meters. So we know the arc length is 20 meters. It's intercepted by a central angle of 35 degrees. Find the radius. So 20 is equal to the radius times the arc length of 35 degrees. Now again, this is in degrees, so we've got to convert it into radians So I would multiply by pi over 180. And then I have to solve that for r. So if I'm going to solve that for r, I'm going to multiply by the 180 to move it over here. So 20 times 180 equals 35 times pi times r, if I just change the order, right? All of this would still be on top. I want to solve it for r, so I still have to divide by the 35 pi. So r is going to be equal to 20 times 180 divided by 35 pi. So 35 shift pi. And I get 32.74. So rounding to the nearest tenth, 32.7, and it's going to be in meters since my arc length was in meters. Now be careful on this one when you punch it in, because I think if you try to do 35 times pi, it's not going to work. You either just have to put the pi right behind the 35 or put that in parentheses. So if you're having some issues, you have a different kind of calculator or something like that, and it's not coming out right, put the 35 times pi in parentheses so that when it's following the calculators, following the order of operations, it comes out correctly. So try to get it punched in, see if you get the same value I do to see how it works on your calculator. On mine, if I just use 35 pi with no sign in between, I don't need to worry about the parentheses, but on some other calculators like a Texas Instrument one, you may have to. So watch that, make sure you're getting the same number so you know how your calculator works.